This video presents a comprehensive analysis of the devastating impact Hurricanes Ian and Nicole had on Ponce Preserve's irreplaceable natural dune system, near Daytona Beach Shores, Florida. The preserve contains the only remaining natural remnant dune along this heavily developed coastline, making its documentation and protection critically important for coastal resilience and ecosystem preservation. The first half of this video compares the LiDAR-based erosion measurement, pre-storm to post-Nicole conditions, while the high-resolution visualization shows elevation changes across the former four-dune zone. It shows scientific methodology using Gaussian smoothed elevation data and three-zone erosion classification. The documentation of the 100-foot dune toe retreat uses comparative geospatial analysis, and three-zone erosion classification reveals 1-13+ feet of vertical sand loss. This video highlights quantitative erosion analysis comparing the baseline conditions of post-Hurricane Milton 2024 to post-Hurricane Ivan 2004, as well as high-resolution visualization showing erosion depths ranging from 1 to 13+ feet of sand loss, and the integration of citizen-captured storm footage with professional geospatial analysis. The loss of Ponce Preserve's four-dune is a catastrophic change to Florida's coast. Ponce Preserve represents Florida's last natural dune remnant in this coastal segment. This analysis documents not just Hurricane Nicole's individual impact, but the cumulative effects of multiple recent hurricanes, such as Ian, Nicole, and Milton, on irreplaceable coastal habitat. The second half of this video is the rare raw footage captured by a resident from a high-rise condominium north of Ponce Preserve during Hurricane Nicole's direct impact. The unique value of combining citizen documentation with professional analysis positions the video as both scientifically rigorous and visually compelling. Hurricanes Ian and Nicole wiped out the natural four-dune. Back dunes remain, and the dune toe retreated approximately 100 feet. These hurricanes, not Milton, were responsible for a 100-foot retreat of the dune toe and the destruction of the natural four-dune. The surviving back dunes now represent the natural remnant dune referenced in this analysis. Waves from Ian and Nicole impacted the east coast of Florida, including Daytona Beach Shores, Wilbur by the Sea, and Ponce Preserve. The last remaining natural dune facing the Atlantic in this area was measured and documented based on wave energy and height. Each hurricane attacked the beach from a different angle. Oblique wave impacts, where wave energy moves along the shoreline, cause damage over long sections of coast. Hurricane Nicole, in particular, generated a powerful and sustained longshore wave force that continued running north along the coast even after the storm's center moved inland. This persistent wave action continued reshaping the shoreline long after the storm had passed. In contrast to developed areas with seawalls that suffered major damage, the full extent of coastal impact is most clearly seen at Ponce Preserve, which remains the only natural remnant of sand in this segment. The combination of real-time storm documentation and rigorous post-storm quantification provides crucial data for coastal management, emergency planning, and conservation efforts to showcase the extent of Ponce Preserve's irreplaceable natural dune system. When comparing the Gulf and Atlantic coasts of Florida under identical hurricane conditions, same storm strength, same angle of landfall, and all other factors held constant, there are notable differences in the type and severity of coastal impacts due to the distinct oceanographic and geographic features of each coast. The first difference is the Gulf side's higher surges. The Gulf Coast of Florida is significantly more vulnerable to higher storm surges than the Atlantic side. This is primarily because the Gulf features a very shallow, gently sloping continental shelf. As a hurricane pushes water toward shore, this ramp effect allows the surge to build up more dramatically and travel farther inland. For example, the same hurricane could generate a 15-foot storm surge on the Atlantic coast but a 25-foot surge on the Gulf Coast, simply because the water off the Gulf Coast is much shallower for a much greater distance offshore. The shape of the coastline and the shallow bathymetry of the Gulf act to amplify surge, making communities on the Gulf side, especially in areas like Tampa Bay and the Big Bend, especially susceptible to severe flooding from storm surge.